How do you pronounce it, Kyle?
Mahowald.
Mahowald. Okay. Is it Irish?
Uh, I found out it's Luxembourgish, that's
Really?
why it's phonotactically a bit strange. Yeah.
Interesting. Kyle Mahowald is an assistant professor in the Department of Linguistics at the University of Texas, Austin. His research interests include learning about human language from language models, as well as how information theoretic accounts of human language can explain observed variation within and across languages. Mahowald has published in computational linguistics, machine learning, and cognitive science, and he has won an outstanding paper award at EMNLP. What does that stand for, Kyle? EMNLP.
Uh, Empirical methods in natural language processing. Although
As
it's
well,
kind of like that, it's part of the ACL family.
as well as the National Science Foundation's Career Award. Take it, Kyle, it's yours.
Great. Okay, let me go ahead and share some. Oh, it's actually says like I think you need to stop sharing so that I can share.
Okay, I'm going to turn myself off.
It's up. Someone is sharing the this Word
Oh,
document
I'm
is being
sorry.
shared right now.
It's me
Yeah,
again. I
yeah.
was sharing that document. It's all yours
There
now.
we go.
Sorry, that's why I couldn't find myself.
Yeah. Okay. Now I should be able. All right. So we should be able to see that.
Yep, that's great.
Okay. Yeah, so today wanted to start off by thinking about a bit about just how far language models have come really in relatively recent years. So this is way back in the ancient history of 2011. Here is some output from what was at the time a high performing neural network. So here's some text that came out of this 2011 RNN. In the show's agreement, uh, unanimously resurfaced. The wild pastured with consistent street forests were incorporated by the 15th century BE. So I don't know, doesn't make a lot of sense really. And if you compare that to kind of anything that a modern language model generates, it's clear that something's really happened here, right? There's been a pretty big jump. And that's kind of what we've all been talking about over the last few days, is that something seems to have really happened. One of these papers releasing this model kind of patted itself on the back as a surprisingly good language model, praised the richness of the vocabulary, said the text is mostly grammatical. The parentheses are usually balanced over many characters, and you may see kind of see where I'm going with this. This is in the 2011 Sitzgever et al. Paper, kind of praising itself as how great it's doing as a language model, when really, in hindsight, we've come a very long way from that point, right? And you can basically, this is from Llama, but for any modern language model, you can generate lots and lots of sentences, which will basically be grammatical. One more vignette to kind of illustrate this point. So the PIPP construction, this is due to Chris Potts in a nice paper last year that was in honor of his PhD advisor, Jeff Pullum. Looked at this really interesting construction, which is the PIPP, which is, if you could say that we were happy with the idea, we decided not to pursue it, that they were brilliant linguists, they just couldn't figure it out. The PIPP construction takes this and then fronts an element. So you get things like this: happy though we were with the idea, we decided not to pursue it. Or though they were brilliant linguists, they just couldn't figure it out, becomes brilliant linguists though they just couldn't figure it out. So this is reasonably rare, but it's going to occur fairly often in a corpus. But Pullum had made this observation, and kind of when Chris was his student, had challenged him, can you find examples like this, where this fronting crosses a finite clause boundary? So this is in linguistics, this tensed verb here creates a finite clause. And so you can say something like, happy though she knew we were with the idea, she decided not to pursue it. And so this is like a little syntactically complicated, but I think for the most part, we'd agree that even if it crosses a finite clause boundary like this, it's grammatical. But what's interesting about this is that this is really, really vanishingly rare. And so in this paper, the characterizing English, preposing, and PP constructions paper, Chris Potts does this nice corpus analysis, and he kind of exhaustively looks for these, and in a corpus of about 7 billion plus sentences, finds 58 of these where they cross finite clause boundaries. And what's really striking about this particular number is that it means that an adult human English speaker might go, 30, 40, 50 years and never actually encounter an example like this in the wild, and yet still agrees it's grammatical. And I think kind of as we've been talking about the last few days, this ability to generalize even to something we haven't seen before really gets at the heart of what we're interested in linguistics. And I won't go into all the details on it, but there's some nice experiments with language models in Chris's paper showing that language models, aren't perfect with this, but actually can generalize pretty nicely to even these finite clause crossing examples. Okay, so those are a couple of vignettes to kind of get started about what we're thinking about. So kind of my overall plan today is to have 4 kind of overarching questions. The first, have language models meaningfully learned any syntax? And I'm going to kind of go through some evidence for that and argue that yes. I'll admit they haven't learned everything about syntax, right? It's possible to trip them up in certain cases. But I think it's fair to say that under some definition of meaningfully, right, it's not all just smoke and mirrors. They really have learned something that I think is linguistically interesting. The second question is, should this information cause us to update some of our beliefs about language processing in humans? And again, here, I would say, like, somewhat cautiously, the answer is yes. And I'll talk a bit about that. I'll kind of raise this question: if language models are black boxes, how can they tell us anything? I'm going to show some work from my own group showing that really they don't have to be entirely black boxes. I'm going to try to, for the first time, run with this glass box metaphor and argue they can actually be pretty transparent, and they're becoming more and more transparent in some sense, right? So kind of small models that we can study and analyze are becoming more and more transparent, even as large models that are closed source and run by big companies are becoming less and less transparent in some sense. And 4, does this mean we should abandon linguistic theory and just do NLP instead, or just do Bertology or LLMology? And the answer is no, definitely not. I'm going to argue that that would be the totally wrong approach, but that actually there's a path towards language models and linguistic theory working well together. And I think this is already happening. And I think some of that's already come out in this summer school, and I hope we can discuss this and bring even more of that out. That really, I do think there's a great path towards connections, and that this is actually a really exciting time at this intersection. Okay, so for this first question, have language models meaningfully learned any syntax? So I think I'm going to say that they do well on tests of syntax. I'm going to make some argument they don't just memorize grammatical structures, but generalize. And that this is kind of in contrast to the fact that in other kinds of realms of cognition, and we've seen a lot of examples of these, they do seem to mess up some other stuff. So on the first point, grammaticality judgments like the kind I was showing with happy though she knew we were with the idea, we have nice methods for studying these from psycholinguistics. But because of the nature of language models, and because we're to some extent trying to study the behavior of a system which is, at least to some extent, black box, it's hard to actually get a good handle on what its knowledge of language is in some sense. And similar, it can also be hard to do that for people. But some of the same methods work, right? So the gold standard that's emerged here, and this is something Richard touched on in his talk on Monday, is minimal pair likelihood comparisons, right? So minimal pairs, a kind of tried and true method in linguistics to change the smallest possible thing you can between 2 sentences or between 2 words or whatever your unit is that you're looking at. And then hope that whatever difference you're observing in your measurement or in behavior is coming from exactly that minimal pair. So subject-verb agreement has been really well studied in this area. So this is knowing that if you say the key to the cabinet, you want to say is on the table, but if it's the keys to the cabinet, it's are on the table, right? This, we'll talk about this a bit more, but this is kind of well studied in part because it seems to require some kind of long distance dependency, right? It's not just the case that you agree with the nearest noun, even though that heuristic might work some of the time. It's that you actually need to have some notion of what's the subject of the sentence. And then when you get to the verb, look back to that subject to know how to do the agreement. And then filler gap dependencies, right? This is work that Richard has been very involved with and talked about, where, I know that the lion devoured a gazelle at sunrise sounds good. I know what the lion devoured at sunrise sounds good, but you can't say I know what the lion devoured a gazelle at sunrise, or you can't say I know that the lion devoured at sunrise. And right, you can do careful minimal pair comparisons, as Wilcox et al. Did, and study whether language models learn phenomena like that. Right. The problem that can make this tricky is that lots of constructions aren't as amenable to these kinds of careful minimal pairs, right? It's hard to devise these kinds of cases. So
Kyle,
then,
Kyle,
yep,
slow down a little bit because not everybody's a unilingual first language English person listening.
yep, sure.
Just slowly.
Yep. I'm trying to go back. Huh. Can't seem to go back. Let me. There we go. Right. So for the filler gaps, right, the kind of key point here is that with these long distance dependencies, I know that the lion devoured a gazelle at sunrise is grammatical. I know what the lion devoured at sunrise is grammatical. But you can't say I know what the lion devoured a gazelle at sunrise, right? And you can't say I know that the lion devoured at sunrise. And so knowing what goes in this slot is going to crucially depend on what happened here. Okay. So the kind of methodology that's emerged is to develop benchmarks and kind of standardized tests for things like grammaticality of the sort we're discussing. And a well-known such example is BLIMP, the benchmark of minimal pairs, benchmark of linguistic minimal pairs, which looks into a bunch of categories, right, that are of linguistic interest. So like anaphor agreement, right? Many girls insulted themselves, in contrast to many girls insulted herself, which is ungrammatical. Rose wasn't disturbing Mark, where the verb disturbing can properly, typically takes an object, whereas Rose wasn't boasting Mark, boasting doesn't take an object, so that one's ungrammatical. Carlos said that Laurie helped him, whereas Carlos said that Laurie helped himself. Right, there's rules about whether you use him or himself here, right? And so these are designed to be pairs of sentences which minimally differ, such that it's basically one word that's going to be the difference between grammatical and not grammatical. And so the method has typically been to measure the probability of the acceptable example and the unacceptable example and do a comparison on those, with the hope being that whatever difference emerges is because of this grammaticality contrast. Right. And what I can show here is that this performance, here we can show performance on BLIMP score, which ranges from 0 to 1 for these baby LM models. So baby LM was a competition to train language models on what were supposed to be developmentally plausible corpora, right? So in contrast to something like ChatGPT, which is trained on vastly more data than a human would see in their lifetime, this was 100 million words was the limit that you could train your model on, right? And then the idea was to see if you could still get something which did reasonably well on something like this BLIMP benchmark. And so human score is here around 0.87. And so on the baby LM corpus, right, on this 100 million word training, the best performing models got pretty close. They didn't quite get to human performance, right? They're around here at 0.3, 0.83, 0.84. And so this is pretty significant progress, although I would say still not quite at human performance. And this is for models which are much smaller than the kind of ChatGPT sized models. I'll give a head. This was our team at UT Austin was in there, so like we did all right, but we didn't win. Okay, so you could then say, well, there's some issues with BLIMP. The minimal pairs aren't perfectly controlled. The sentences are a bit artificial. And so there have been other proposals, like there was a recent one in PNAS from this Dentella et al. Paper to look at a bunch of interesting grammaticality contrasts Uh, and instead of using minimal pair comparisons, look at some important difficult phenomena like anaphora, center embedding, long distance agreement, and um, basically ask the models whether or not they're grammatical, right? So here is an example. Here are a couple examples, right? So the babysitters that no child obeyed have shown any gratitude to the disappointed parents, right? This would be considered ungrammatical because, right, the babysitters that no child obeyed have shown any gratitude. This is a negative polarity violation. Um, Whereas, something like no ambassadors that the diplomats consulted have ever seen brutality in the foreign war is grammatical. And the method here is to basically just ask the model, right? This is using models like ChatGPT and GPT-3, which you can interface with in natural language much more easily than smaller models. And basically ask the model, is this grammatical or is this not grammatical? And a reasonable goal, right, is to say, well, if people can do that task, then so should models. Um, but the problem is that if you're asking for a grammaticality judgment from a model just by asking it, is this grammatical? You're kind of mixing two things. You're mixing what the model in some sense knows about language with what the model knows about what grammaticality is. And so I think there's a kind of thought experiment which makes it, I think, easy to see this difference, which is that if you imagine training on a corpus where you completely removed the word grammaticality from the corpus, it's gonna turn out that the model has no idea what grammaticality means, right? And so by asking the model what's grammatical, you're tying up these pieces. And another issue, right, is without minimal pairs, you can't do this likelihood comparison. So this Dentell et al. Study found that models were actually pretty unimpressive across the board at these categories. But in a follow-up study led by Jen Hu, and with me and Gary Lupian and Anya Ivanova and Roger Levy, we looked at a response to this where we got human acceptability ratings. That's what we show here on the y-axis. And then created minimal pairs for these sentences, right? Looking at the differences in surprisals, and then plotted them against each other. And what you actually see is pretty nice correlations between human judgments and model judgments. So these are for two of the OpenAI series of models. And what you also see here, right, is that there's actually quite a lot of gradients in grammaticality judgments. So one of the categories here is adverb order. And you've got sentences like Gary still perhaps drives to work, which in the data set is labeled ungrammatical, but people actually were pretty mixed on that, right? That was the case where there was quite a bit of mixed judgment. And then there's also cases, I'm going to skip center embedding for now. There's cases like anaphora, where getting the judgment depended on singular they being ungrammatical. But this is something that's rapidly changing in the lexicon, right? So the grimy blacksmith who worked for the Royal Knights evidently hurt themselves with the sharp tools. Here, this was labeled ungrammatical in this set, but themselves, right, could, if you accept singular they, which many people do, refer here to blacksmith, right? And so people were kind of mixed in these judgments, and models were also mixed. And so what you actually see is a nice kind of range of grammaticality here, such that some are kind of more clearly grammatical, some are more clearly ungrammatical, and there's a middle, and models and humans seem to have some alignment on that. Okay, so that's some evidence that there's some alignment between humans and models. But as we've been thinking, right, we should also consider alternative explanations for what could be happening here. So specifically, we should think like, is the model, as has been argued by many, just doing this kind of stochastic parrot activity and spitting out what it was in its training corpus? And I think there's evidence that it's maybe doing more than just that, right? So there is a nice paper from Tom McCoy et al. Called Raven, where they look at if you just generate from a model. So this was a GPT-2 type model. The transformer is like a GPT-2 type model. How many of the engrams that are produced tend to be unique? And you can compare that to a human generated corpus, And what you see is it's actually the case that once you get up to like 5 or 6 grams from both models or in a human corpus, right? And 5 or 6 grams, right? These are 5 or 6 word phrases essentially. What you're seeing is that most of them tend to be unique. And by the time you get to around, 9 or 10 word phrases, they're almost entirely unique, whether generated by models or by people. Right, so this is some evidence that it's not just the case that models are spitting out what they've seen before. Right, we could also, there've been lots of clever tests looking at our models just using lexical cues in some straightforward way. So there was a paper looking at the subject-verb agreement test, where instead of using sentences which are plausible, like the key to the cabinets is on the table, using sentences in which words of the same part of speech are randomly substituted in. So you get stuff that actually sounds kind of semantically empty. Like it presents the case for marriage equality in states, becomes it stays the shuttle for honesty, insurance, and fines, right? So the first one makes sense. The second one is kind of semantically empty. And they found that models were actually still able to do the grammaticality task, even without these kind of obvious lexical cues that it might rely on that you get from having semantically reasonable sentences. And then there was just a week or two ago, this paper posted from Patil Umale et al., which was this really nice pre-training paradigm. And I'll show some examples from my own group about a pre-training paradigm in a bit, where they went into the input corpus and then messed with the input such that you never actually see a subject. So here, a sketch of a light doesn't appear versus a sketch of a light don't appear. They mess with the input such that you never see a subject modified by a prepositional phrase in the input, and then test whether models still know that the verb has to agree with the subject and not the prepositional phrase item. And right, you've seen prepositional phrases in other places, and so you can still learn what they are. And models actually seem to do that surprisingly well. So a bit more evidence of generalization. So that's a bit of a case, right, that they're not just stochastic parrots. But I think one of the things I've been arguing for recently, right, is that we should consider more than just core phenomenon here. There's also a lot to think about in terms of how language models learn rare or unusual construction. And so there have been some nice position pieces from Adele Goldberg and Leni Weisweiler and others making this point that something that language models are actually quite good at and that it's interesting to explore is kind of rare constructions which are sensitive, not just to these higher order grammatical properties, but that interact with lexical items in particular ways. So I think one nice example of that that I'd like to talk about a bit is this AANN construction. So this is the article, adjective, numeral, noun construction, which is this kind of quirky construction in English, which is, this is the kind of default way you might say this, right? The family spent 5 beautiful days in London. But English has, I don't think it has to be this way, but it turns out that in English, you could also say, the family spent a beautiful 5 days in London. Right. And what's weird about this is that you've got this singular a, right? Usually a goes with a singular noun, but here a is taking a plural noun, days. And this is a bit unusual. It also means that you swap the normal order of the adjective and the numeral. So normally it'd be 5 beautiful days, but here it's a beautiful 5 days. And what's interesting about it is the A is obligatory. So you can't say the family spent beautiful 5 days in London. The A can't do its normal thing of taking a singular noun, right? You can't say the family spent a beautiful 5 day in London. And yet for the non-linguists in the audience, these stars mean it's ungrammatical. And the modifier is obligatory, right? You can't say the family spent a 5 days in London, or at least that's often judged as less good. And like I mentioned, you've got this kind of requirement that whereas normally 5 becomes before beautiful, here you've got the opposite, and it's obligatory, right? So you can't say the family spent a 5 beautiful days in London. It's a beautiful 5 days, right? So what seems to be happening here is that this 5 days is being coerced into a kind of singular unit that takes an adjective and an article, which is normally singular. So this first paper we're going to mention here, I looked at, oh, yeah, before we get to model results, right? The adjective, this construction is also constrained in interesting ways by the words in the construction, right? So the adjective can be quantitative, right? You could have a mere 5 days, a whopping 6 hours. It can be qualitative. This works best with measure nouns, but also some others, right? So you can have an amazing 5 days or a lovely 6 hours. In these cases, amazing and lovely are modifying the days and the hours. Whereas if I say a mere 5 or a whopping 6, in those cases, those are modifying the number itself. And interestingly, they can't be stubbornly distributive. So a blue 5 pencils, right, just doesn't sound right to most English speakers. The noun, right, is typically measure and unit nouns, although it also works, right, a mere 5 hours, but it also works with other kinds of nouns. So you can say I had a mere 5 pencils left on my desk. I'm going to skip through a bit faster here for time. Okay, so what we then did here was looked at prompting a GPT-3 model to get ratings, grammaticality ratings for these constructions, varying a whole bunch of properties. So varying the nouns, varying the kinds of adjectives you see in there, and then getting human comparisons using getting human ratings for these sentences of Mechanical Turk. So these triangles represent the human ratings, and the bars here represent GPT-3 ratings. And what we see is we get actually quite a lot of similarity between model judgments and human judgment as to how much they like these different sentences. So what you see here is that both humans and models prefer that the adjective be quantitative. So like a mere 5 miles is somehow better than a great 5 miles. An astonishing 100 students is better than a tall 100 students, right? So these stubbornly distributed ones, like color words, right, are less popular. Again, right, a whopping 5 pencils and an elegant 5 pencils, models and humans rate better than a blue 5 pencils. That's what you see. These lower bars here are for things like a blue 5 pencils. And then you get this other effect, right, that for qualitative adjectives, those are just about as good with temporal, right? So a great 5 hours is about as good as a mere 5 hours. So I'm going through that a bit fast, right? But the kind of takeaway is that even for a relatively rare and quite specific construction like this, we're seeing some reasonably subtle similarities between model and human ratings of these sentences. And then the last thing I'll say in terms of grammaticality, right, is that it seems like language models kind of pass the smell test on grammaticality in some sense, right? So you can generate lots and lots of text from language models. You can do this with ChatGPT, for instance. And by and large, it's going to be grammatical, right? It's much harder to find examples, right? Linguistics gives us lots and lots of plausible, examples of ungrammatical sentences that if you learn the wrong rules, maybe you'd have learned this, right? Like, is the man who tall is happy, right? That's not how we form a question. And language models, like modern language models, by and large, aren't going to generate things like this. There are, right, rigorous tests. And so when Roni and Richard were talking about across the board movement, right, you can get into cases like I know who John met recently and is going to annoy you soon, which are quite subtle. Right, like I could even imagine some prosody where maybe this one could be made to work. And models might get tripped up there and diverge from human judgments. But I think it's kind of striking that we've kind of gotten pushed into these cases which are really very sensitive, as opposed to kind of these kind of easier to get cases. This, I think, is in pretty sharp contrast to these examples we've been seeing from others, right, talking about things like language understanding or more general cognition. So over here are some examples from, like here's from Josh's talk, right, where you show a model this blurry word and it says that it's a person with short hair and wearing a shirt with a collar, right? I feel like like many of the talks in this that we've seen this week have involved these kind of funny and striking examples of models being really silly, those are pretty easy to get still in reasoning and kinds of different areas of cognition. Those examples are harder to get in terms of grammaticality. And so I think there's some difference there. And so I would tentatively argue that, right, models, we have to keep pushing on them to see if they're relying on tricks or heuristics, but it seems like they have learned something about grammar. Right, so we could ask, should this cause us to update some of our beliefs about language processing in humans? And I would argue that from the perspective of 10 years ago, the success of language models is surprising. And so with that surprise does come some information, right? And that we should think about that seriously in terms of how we have been thinking about some linguistic questions. And then I'll briefly go through a case study looking at grammatical subject to illustrate that. Right. So this is a position piece I'll mention that I wrote with Anya Ivanova and F. Fedorenko and others, asking, looking at this language and thought separation, right? And so one reaction that people seem to have is, well, okay, language models have gotten good at getting the form of language right, but who cares anyway, right? Isn't the interesting thing how they think and reasoning? But I think from the perspective of linguistics, this really does matter and is something that we can think about, right? And this was something, we can come back to this, which Richard had mentioned, right? Which is that going back to 1957, Chomsky had this famous statement that colorless green ideas sleep furiously versus furiously sleep ideas green colorless, right, is an important contrast. And the claim was this could not be identified in any way with the notion higher order of statistical approximation to English, because it is fair to assume that neither sentence one nor two has ever occurred in an English discourse. Hence, in any statistical model for grammaticalness, these sentences will be ruled out on identical grounds as equally remote from English. And I think in a meaningful way, we've seen that models, even without being explicitly trained on things like parts of speech, kind of emergently learn them well enough to know that they can rule in this one and rule out that one. But this really wasn't obvious that this could happen kind of at scale until really quite recently. And so here's from 2006, right? The question of learnability and the potential need for innate constraints remains. Machine learning methods have successfully learned small artificial context-free languages, but profound difficulties in extending these results to real language corpora have led computational linguists to focus on learning from parsed trees, presumably not available to the child. Connectionism is no panacea here. Indeed, connectionist simulations of language learning typically use small artificial languages, and despite having considerable psychological interest, they often scale poorly. Right, and so this is from actually Chater and Manning, right, in an article which was very pro probabilistic methods of language. But in 2006, right, it still just didn't seem like something that didn't have a lot of really richly built-in syntax was going to be able to learn much, right? The same was true, in 2011. Here's a paper from Josh and others writing about connectionist models sidestep these challenges by denying the brain encodes rich knowledge. This runs counter to the strong consensus in cognitive science and artificial intelligence that symbols and structures are essential for thought. There's a really interesting paper from 2014 by Marco Baroni et al. Called Frege in Space, where they propose this totally fascinating kind of compositional method based on distributional semantics that's really kind of close to imagining what language models would be able to do in terms of putting together compositions. But just kind of doesn't take the next step to assume that just by training on next words, you end up getting a lot of these kinds of things. Here's Everart et al. Saying, for these reasons and others, usage-based approaches that reject generative procedures and apply statistical methods to analyze data fail to distinguish these cases, right? And compares cases like how many cars did they ask if the mechanics fixed to how many mechanics did they ask if fixed the cars. Right, and I think this is, again, a case that language models probably would be able to, at this point, tell apart these just based on, statistical methods. And then in 2016, I think within linguistics, it's really this Linzen et al. Paper, which shows some, in hindsight, very limited success in getting an LSTM, which is, an earlier kind of language model, some limited success in a subject-verb agreement task. So this is that keys to the cabinet or on the table kind of task. Um, and it worked only with specific training. But they still conclude, right? LSTMs are sequence models. They do not have built-in hierarchical representations. We have investigated how well they can learn subject-verb agreement, a phenomenon that crucially depends on hierarchical syntactic structure. And when provided explicit supervision, LSTMs were able to learn to perform the agreement task, although their error rate increased on particularly difficult sentences. Right, so this was like a very small success on this task using just an LSTM. But then from there, right, there's lots of unexpected success, right? The 2017, the transformer comes around, and there's Elmo and Bird and GPT-2. I think we've kind of seen this story now of GPT-3 and ChatGPT and Baby LM, which is doing with smaller corpora. And you really see this explosion in these methods being successful in kind of detecting and generating grammatical sentences. And so I think there's, insofar as, there are claims in linguistics, and I mean, this was something I believed 10 or 15 years ago, that we would not see models which could do this well just by being trained on a word prediction task or, the language modeling objective in terms of learning grammar. That this should, insofar as there was questions that depended on the answer to that being no, it might push us more towards thinking more towards this LLM view, right? That, how much memorization versus abstraction is there in language, right? So Adele Goldberg has argued for a while that a lot of language learning actually depends on memorization of not just words, but also chunks and phrases and constructions, right? The LLM view seems to kind of naturally fit with that in a bunch of ways. Does processing happen in discrete layers? So, right, language models do a lot of mixing, right? So there are some kind of layer-wise effects, but there's also a lot of mixing that happens. Questions which we can come back to about how much is in the data and what are the biases and disorders, what's the basic unit, and so on. I just want to skip ahead in the interest of time. So let me just skip. I just want to skip this section. I can come back to that later. So what I want to then ask, right, is how can we use language models, right, to actually study and tell us something about language if they're black boxes? And right, kind of this question of, well, why, if we are really interested in studying what humans do, and human minds are already black boxes, what do we get by, instead of studying that black box of human minds, studying language models instead? And I think an argument I want to make there, through, again, a case study of this same construction I talked about before, the AANN, is that really we can think of them maybe more as glass boxes. So this is a new metaphor I'm trying out, which is that, right, models are more than just ChatGPT. We can actually, if we are in control of the model, so training the model ourselves, studying the model ourselves, and not just relying on something from OpenAI, we can actually see into them and understand something about them. Right, but kind of pushing on this glass box metaphor, right? It's easy to get kind of blinded by glare, or you might drop the box. Right, there's lots of ways to do this and get the wrong answer, and so we have to proceed with caution and good experimental methods. And so, yeah, I wanted to illustrate a kind of case study of this in work with Kanishka Misra, who's a postdoc with me, kind of pushing even further on this AANN construction, right? So this is the A Beautiful 5 Days construction. And looking a bit more into that in a more glass box kind of way, right? So we had this idea that, could we use this to study how language models learn rare things? And our hypothesis was that they do that, right? A model could learn rare things like the AANN by analogy to learning less rare things, right? And so AANN's, the method here is going to involve not just taking an existing language model, but training our own language models on highly controlled input corpora. And we're going to do that and then look at how well it learns the AANN, specifically by looking at, does it learn to assign higher probability to the AANN A Beautiful 5 Days, compared to all these degenerate alternatives that we talked about, like A5 Beautiful Days, A5 Days, A Beautiful Days, and Beautiful 5 Days, right? And we're going to train an autoregressive language model. So basically a GPT-2 kind of model. This is actually an OPT, but it's the same idea, with a relatively small number of parameters. And we're going to train it on the baby LM corpus I mentioned. That's 100 million words, which is believed to be kind of within the realm of what a 10-year-old child might have accessed. And we're going to systematically mess with the corpus. Specifically, we're going to find all of the A and N constructions in the corpus. There's around 2,300 of them. And we're going to get rid of them. And then train a model again and see what it's learned. Right. If the model is purely just memorizing and not doing anything very interesting, if we get rid of the A and Ns, it's not going to learn anything about them. But if it's doing some kind of generalization, we might expect some more interesting kinds of behaviors. So specifically, I'm going to show a few different kinds of tests here. So this panel here, we're going to be testing how well does the model learn the A&N construction, right? A Beautiful 5 Days. And we're going to compare across 4 different conditions here. In the first one, chance here is very low because it has to say the A&N is better than all the other alternatives. In the first one, this is just the default condition where we train on the regular corpus. And our small model does okay. It's just below, these skylines here are like large language models on this task, right? And so our small model is just a little worse than the large models. Then we're going to try it on this corpus that we messed with, where we got rid of all the A&Ns. And it takes a sizable hit, but it's still way above chance, right? So here it's like at 46% or something, right? And chance is down here at what is chance? 1/16, right? So this is way, way up here. And then as a control, we're going to compare this to we're going to go into the input corpus. Instead of removing all the A&Ns, we're going to replace them with ANANs, right? Which is A5 Beautiful Days. And then do another version where we replace them with NAANs, right? Which is a quite strange thing, which is 5A Beautiful Days, right? Which sounds totally bizarre. And then figure out if those get learned. Figure out if we train on those, you still learn the ANN. And the answer is, like, in all of these cases, whether we get rid of the ANN or we train on this strange version, you still kind of learn better than chance or in the AANN. Okay, that turns out to be in sharp contrast to if we try to test for its learning of the ANAN of 5 Beautiful Days. Right, so now we're going to be testing, like, can we get the model to learn A5 Beautiful Days? If we train on the regular corpus, of course it doesn't. If we get rid of the AANN, of course it doesn't. If we artificially insert NANs, it does learn it a bit, but nowhere near as well as it learned the AANN when those were in there. And if we put NANs in there, it doesn't learn anything. And now, again, we're going to test, can we get it to learn 5A Beautiful Days? And again, it learns it a bit when we put exactly that structure into the corpus. But it's, again, not nearly as good as the ANN. So what this suggests, right, is that it's not just the case that any old version of this construction can get learned by the model. There's something special about the ANN relative to A5 Beautiful Days and 5A Beautiful Days. What's special about it? So we had some hypotheses, which is that there's other stuff in the language, right? It's not just that constructions exist in isolation. There are other things in the language that seem like they support this, right? So you also can have things like a few plums, or 6 months is a long time, where a measure phrase is treated as singular. And I'm not going to go into a ton of detail on this, but these are much more frequent. Something like where a measure phrase is treated as singular is much more frequent than the ANN itself. And if we get rid of these more frequent things, those actually show quite significant hits on performance. So the claim that we want to make is that language models are showing some evidence of this structure in the language, such that this very particular and rare structure, the ANN, is learned in part by shared structural similarities with these more common structures. Right. And so takeaways on this section, right? It's not the case that it's a black box. And in doing a study like this, we know exactly what's in the training data. We know exactly what's in the input, and we know exactly how it's trained. And we could even stop it at various points of training and figure out what it's learned at each time point. So this is very, very, this is a ton of control over kind of all the aspects of this training process. And all the aspects of the testing procedure in a way that we can't get with humans, right? So it's not just replacing one black box with another. I think it's giving us an additional tool here. But at the same time, right, we have to be careful with the glass box. So our own experiments had some issues with, when we're trying to remove AAA and N's from the input, that turns out to be really difficult. And so, right, we're still like have ongoing updates to that process. And so the need for good experimental methods is very real. So an idea in Roni's talk, Roni mentioned some key aspects of competence include constituency, right? So knowing that talk to Kim, John Will is better than talk to John Will Kim. I actually had the thought that this would be something I think that could be very amenable to testing using this similar kind of method to the ANN, right? So there's a prediction that LLM should prefer this one and disprefer, not disperser, that they disprefer this one, talk to John Will Kim. I suspect they will because these kinds of constructions occur, but what would be really interesting, and I think maybe would get more at an interesting question, is like this should be true even if we remove examples of this fronted structure from training. Then the only reason it should prefer this is because it learns to think about constituency. So maybe there's some interesting thing to explore here. Okay, and then to conclude, I wanted to finally consider this last question about a path towards an interdisciplinary and informed linguistics. So again, inspired by yesterday, I think there's a potential for a kind of Denetian take here. And Ryan Neft has this really nice book on philosophy of linguistics, who's the first I know of, though maybe it happened before, to propose this idea of linguistic theory as real patterns in the Dennett sense. So real patterns in the Dennett sense, right? He uses this example of the game of life, where you've got some grid worlds and then a very particular set of local rules for doing manipulations in that world that can then give rise to these much larger patterns. And this is Conway's game of life. And he has this idea that, okay, maybe you can understand everything perfectly just by looking at this lower level, but whatever's happening at this higher level is a real pattern, right? It's and you're not understanding the system fully unless you're understanding things at a higher level also, right? And so linguistic theories in this Neft real pattern sense are compression algorithms, right? Language models are also compression algorithms, and as Richard said, right, they're the best ones we have for language in practice. And so, as Dennett says, the pattern is real if there's a description of the data that is more efficient in the bitmap, whether or not anyone can concoct it. And so if language models are learning an efficient compressed representation of the data, and the data is being generated by something which has this underlying structure, if they're doing a good job, they should really be learning that also. And so I think this is the theme. Tom Griffiths has written about this, and Eva Portlands' talk also kind of talks about this in terms of cognitive realism. This idea that it's important to think about not just the kind of lower implementation level, but to think of linguistic theory as providing and studying these patterns at the higher level, right? Also, I think Richard and Carl Friston's talk also talked about kind of information theory as a potential bridge between things, right? Insofar as language models are compression algorithms and theories are compression algorithms. Information theory is a really natural way to study compression algorithms and think about those connections. So I think there's a lot to think about there. And then we could get to this question of, kind of underlyingly thinking about these different levels. In what sense should we actually expect to find, say, representations of syntactic trees in language models, right? So something like the key to the cabinet is on the table, where is has to agree with key. The best explanation for that that we know of is that there's such a thing as a grammatical subject, and there's some kind of hierarchical structure. So regardless of how much intervening material there is here, the verb is going to agree with the subject, right? And so, you know, maybe a model is going to be able to solve this problem without explicitly representing a grammatical tree or hierarchical structure. But that doesn't necessarily mean that we should describe that uh, without that, right? And so Dennett, a kind of on intentional language, I've crossed out intentional language here and put language without appeal to linguistic theory. This is my own, just to be clear, my own edit here, right? So Dennett, but this modified version of Dennett, certainly we can describe all processes of language without appeal to linguistic theory, but at enormous cost of cumbersomeness, lack of generality, and unwanted detail. We would miss the pattern that was there, the pattern that permits prediction and supports counterfactuals, right? And so, like, one answer, right, is that I think grammatical theories can be useful and real patterns, even if they turn out not to be explicitly there as representations in the brain, or explicitly there as representations in models. And then answer two is that if the behavior is being captured by a language model, right, and it's not just a trick, it's not just the case that it's doing some kind of cheap heuristic, right, then we might say that the language model is instantiating that real pattern. And I think this is what's happening to some extent. And then that becomes a really exciting avenue to explore, which is to see how can a system like a language model be giving rise to that real pattern or that behavior in a way which we actually have a lot more granularity and control over than human brains. Yep, that, right. So like I've been saying, kind of underlying all of this, I think, and this project is the need for really good experimental methods. So certainly it's possible to be right for the wrong reasons. So McCoy et al. Had this nice paper showing that if you're trying to do a natural language entailment task, it turns out that models will happily pick up on the fact that uh, it often a sentence which is entailed by another sentence has a lot of overlap in words. And so models might say that the doctor was paid by the actor means it's logically true the doctor paid the actor, even though that's obviously not right, right? Just it's relying on some cheap trick. Other examples of that, Wei et al. Had this nice example showing that combat, it's hard to get combat to take the third person singular S merely because combat is frequent in corpora relative to combats. And so it just kind of doesn't like to generate that as much. Right. And so we need to push on these kinds of cases where it turns out the model is doing something dumb or boring or not the kind of human-like generalization we're interested in. But I think linguistics and cognitive science and psycholinguistics have left us, I think, well prepared for that task because we have to think about the same kinds of confounds and alternative explanations when designing human studies and doing work with humans. Right, and then I guess the final thing I think to say, right, is um, there's a huge amount of work now going on in sorry, animations got messed up here, right? In causal abstraction and mechanistic interpretability and counterfactual pre-training and all kinds of methods for trying to better understand what's happening in here, right? And this goes back a long time. Smolensk in '89 said we should develop new formalizations of the fundamental computational notions that have been given one particular formal shape in the traditional symbolic paradigm. And so here I pulled from Roni's talk, right? The massive parameterization of the LM theory, on the other hand, amounts to saying that human linguistic cognition cannot be understood. So I would not say that it can't be understood. I would say we need better methods. And that I do think there's hope that we can understand this black box better. So right here is from Aurora et al. Some really nice methods for studying causal interventions, using causal interventions to study grammaticality and how grammaticality emerges. And so I'm optimistic that as these methods develop, we'll get more and more insights into how these kinds of linguistic real patterns are being implemented in models. So I'm just about out of time here. So I had, I know Roni is responding, so I had a couple of kind of preemptive responses to what Roni's talked from before, but maybe I'll come through that in a bit. Let me go back. Uh, and let me I think end there and take uh, questions and comments. And yeah, thanks to all the collaborators who are listed, pictured here and kind of loosely organized by projects I worked with them on that I mentioned. And yeah, I'm looking forward to further discussion.
Thank you. Yeah, that was terrific. Again, so you've done 2-star performances here. But since Persian rugs are never perfect, I had to turn on the CC while you were talking because it was there was too much of a divergence between what your lips were saying and what the words were. And you want to, it's a trade-off. We got a lot of benefits out of turning on the CC because we saw how I don't know which model is behind this translator or how it gets things wrong. But that happens in this sense. We're also like the model. We get things wrong in our heads if you talk too fast as well. You need feedback on that, just like the models do. Here's the feedback. But it was a terrific talk. Ronnie, it's your turn.
Thank you, Stephen. And thank you, Kyle, for a great talk. I really liked it. And my main difficulty as a commentator is that I agree with most of what you said. So I'm not sure I'll have a lot to say here in the commentary. So I'll go quickly over the 4 main points that you started from and try to highlight kind of where I agree, which is kind of easy, and a few points where I either disagree or would be happy to hear a bit more about the way you see things. The first point was about whether LLMs have meaningfully learned any syntax, and your conclusion that yes, not everything, but yes. And I think, I mean, I generally agree with that, but I think that a lot depends on how we understand meaningfully and for what purpose it is. And of course, there can be so many different purposes here for meaningful learning, and from the completely engineering oriented, good enough for all kinds of products, through meaningfully enough to help us reason about models of cognition, and all the way to kind of meaningfully in the sense of really being like us. And for some of these senses of meaningful, I think, yes, absolutely. I mean, these models are really quite striking, and they clearly learn a lot and will probably continue to learn more with further improvements and developments. I'll come back to the one sense where I think they haven't learned meaningfully, which is kind of being like us. But I think for many other senses, including for senses that are very relevant for cognitive science, yes, definitely, I completely agree with that. Should this cause us to update our beliefs about language processing or about cognitive theory in general? Here, I think it gets more complicated and more, maybe more controversial, more interesting, and I'll come back to that in a moment. LLMs don't have to be black boxes. That was the third point. Absolutely, I completely agree, and I think it's really interesting and important to try to get to the glass box version. No need to abandon linguistics. That was the fourth point. I'm certainly not going to argue with that. So that leaves us with the second point about should this make us update our cognitive theories, basically, and I think that so from where I stand, the answer is that there could be all kinds of interesting updates that would come out of examining LLMs. I'll try to mention one or two, and there can probably be more. But up until now, I haven't seen any real case for updating any major chunks of linguistic theory or cognitive theory in general. Again, this doesn't rule out future revisions based on LLMs. It's just that I haven't seen cases or compelling cases of this kind. So I'll go quickly over some of the arguments that I listed a couple of days ago for that linguists use, the kinds of reasoning that linguists use for constructing their theories. Some of these are much broader than just being about language. Something we ended up talking about walking and other things the other day. Some of these things really are quite broad. Some of them are narrower. And so one was the distinction between competence and performance, and so for many cognitive processes, we can see that humans do one thing when they're relaxed and they've slept well at night and all that, and they perform quite differently when they're under time pressure and all that. And again, it can be things from walking to putting together words, subtle errors of different kinds, and they can correct themselves when they're given more time and all that. And with LLMs, in some sense, this is a case where it's not exactly a black box, because we can look at at least the open models there, not the OpenAI ones, but the actual open source ones, and see that they don't really have a separate notion of a meaningful separate notion of competence and performance. And so for cases like the Gulordaba examples that you mentioned, and with these beautiful alignments of the performance of models, earlier ones for that paper, as you mentioned, and human judgments, and those other cases of alignment, yes, those alignments are striking, but including the errors. But the human errors are very different in exactly this sense, that given more time, humans will, or a quieter room, or better rest, humans will say something different, and the models will not, which is not surprising, because we know that they don't have a separate sense of resting or something like that, at least not yet. I mean, one can imagine different models that will have that, but current models don't have that kind of distinction, and that's a significant architectural difference, at least with current models. Similarly for probability versus grammaticality. So when in those tests that are aimed at grammaticality evaluations of models, I think there is a real issue here that the models, and again, this is something that is not a black box for the open models, because we can see that they only output probabilities. They only tell us what's likely. They can't, architecturally, they can't tell us that this is likely but incorrect. They don't have two separate channels. They just tell us what the probabilities are, and humans do. So we do have this distinction that help us make distinctions that are significant. And so those cases where we have something that's completely surprising but true, on various levels, and other cases that are actually quite common but incorrect, like agreement attraction or problems with center embedding and so on. Again, current models don't have that distinction. I think it's a place where it can be interesting to think about how one might design future LLMs that will have that distinction. I think it's a very important distinction for lots of different reasons and in different ways, and it can be an interesting challenge. But and so the grammaticality judgments that people have looked at, including in that work that you mentioned that we did, we also try to reason about grammaticality from these models, but it's always from these probabilities, and those are two separate notions. So you can try to make all kinds of inferences about what some other model would say about grammaticality, but it would be a model that would have grammaticality, and these models don't. And then the evidence that linguists have used over the years to reason about and make certain claims about representations and about the learning process, and those include things like the argument from the poverty of the stimulus, and the typology, the fact that it's not just that English has this thing about only constituents being able to be there in the beginning of the sentence in a non-canonical position, but that this notion of constituency appears in language after language, and lots of other such cases. And here, yes, I can easily imagine an LLM showing us that, for example, that something that linguists thought had an argument from the poverty of the stimulus uh, uh, supporting it is actually easily learnable from 8 years of linguistic experience. I don't know of such cases yet. I mean, it's quite possible that we'll find such things. I think in the places where people have looked, including where we looked recently, following Richard and others, so far we haven't. I'm not aware of any case where linguists really thought that there was an APS, an argument of this kind for a particular thing, and LLMs disproved it. Again, this could happen tomorrow, but so far we haven't found such cases, or at least I'm not familiar with such cases yet. Similarly, for the typology, the fact that certain things appear in language after language and other things don't, and the particular skewed distribution for things, because some things can have exceptions, but still it's not noise. It's possible that LLMs will help us reason about that and conclude that this interesting pattern that linguists thought supported certain properties of particular programming languages that they've proposed actually can arise from completely different programming languages, so different universal grammars like an LLM, as a theory of UG with programs being configurations of weights, and maybe it will turn out that this thing really doesn't need to follow from what linguists have said. But again, I'm not familiar with such cases. So as far as I'm aware, existing arguments from the poverty of the stimulus and existing arguments from the typology still stand. I'm all for continuing to look at these cases using LLMs, but as far as I'm aware, these arguments still stand. And the learning itself, which is in a way also a bit of an argument from the poverty of the stimulus. So you had on that slide, I mean, among other things there, that example with the A's and the B's and the C's and the D's, and where humans can look at just a handful of examples and systematically reach a certain conclusion, and no current model does the same. So we seem to still learn in very different ways. So about whether we need to update our theories of cognition, or particularly linguistics, I haven't seen the evidence yet. I think all the existing arguments for those existing proposals still stand, but I do agree that LLMs provide a fantastic tool for re-examining these arguments and maybe eventually reaching different conclusions. So I'm all for that. So yes, so with this mostly, as I said, I mostly agree with what you said, and I think it was extremely interesting. And so I'll stop here. Yeah.
Kyle, do you want to respond to Ronnie, or do you want to start with your questions?
Yeah, there's a bunch there. I guess I could maybe the part to briefly respond to is just thinking about, so like the example that Ronnie mentioned, which I've taken from his slides of, counting A's and B's, which models kind of often fall apart with counting, and things like this, I think taps into something that we talk about a bit in this position paper I mentioned about formal and functional competence, that models have all these failures like we've seen with whether it's counting or reasoning, and I feel like sometimes those can bleed in to language. And so like center embedding feels like a case like that, where I've seen some, that models might be helped by like things like chain of thought, or that are used to help models reason better. Like you're having a scratch pad. Those kinds of things seem like they might be able to help it be able to figure out like some, quadruple center embedding kind of sentence. But that feels like a bit different from their ability to do kind of like on the fly language production and grammar. And I feel like the same kind of distinction also we run into like when you're saying it would be great, and I agree, it'd be great if we could like in some sense just ask models what's grammatical and what's not grammatical, and have them give an answer which was separate from just probability and likelihood. but then that again is getting into this space of it, I don't know if you would agree. That feels like that's then asking models to also do something which is extra linguistic, which is to be able to reason about grammaticality. Um, and in terms of like wanting models that are kind of human-like in some way, that seems totally fair. But it feels like it's something separate from its linguistic abilities. Does that make sense? Or do you think that those are inseparable?
So I'm not sure what would so um, are we talking about whether this still allows these LLMs to be good theories of who we are, or
Yeah, well,
can we?
specifically,
Yeah.
specifically who we are linguistically. I feel like there's the kind of overall cognitive package, which would involve being able to reason and kind of do metalinguistic reasoning about what's grammatical and the difference between what's grammatical and what's likely, as opposed to just the ability to produce consistently grammatical text. Um, right, and so it's I could it's something that kind of I've talked about a bunch, and like that in the Gen Who response paper we talked about a bunch, that it's easy to imagine a model, like imagine a model that had perfect grammatical knowledge and could just never make a grammatical mistake, could produce constructions perfectly, but was unable to tell you what was grammatical and what wasn't. And you'll like that. I don't know. Yeah, would that be missing something fundamental about linguistics, or would that be a failure, like another kind of cognitive failure?
So I don't know.
Yeah,
We
yeah,
we do have these distinctions. So since
yeah,
the best theory of how we can deal with these, on the one hand, surprising sentences that we were okay with, and on the other hand, common sentences that we reject. And that's for the likelihood versus grammaticality, and the other thing is the competence performance, or how we manage under different resource
yeah.
burdens. Those are major properties of our system. So if LLMs at this point, and at least for the models that we can look at, they really don't have that distinction. We can try to make them give us something that approximates it, but they're designed in a way that doesn't have that distinction. So that makes them different from us in fundamental ways. And then similarly, for all those many cases where it looks like they don't learn what we learn from similar data. And if you use them as the basis for agents in language communities, they would give rise to completely different cross-linguistic patterns from what we see. So that makes them very, very different from us in terms of their representation and learning. Again, complex, interesting objects in their own right. And one can think about what it would take to make them more like us in terms of either those architectural distinctions or the specific representations and learning. I think that those are extremely interesting questions. But at this point, for all these major points, they're just too different from who we are. So when we try to reason about what the best theory about who we are, it's very different from what they are. Which is fine. I think it's still useful to use them and to consider them. It also helps reason about these things, which is very good. I think it helps sharpen these points in ways that were very difficult before.
Okay, Gary,
Yeah.
you're on.
Yeah, I have a comment on this very topic. So the reason, and I'm finding myself more in agreement with, I think, Kyle's point, and let me try to rephrase it maybe a little bit, which is running in your talk, the example of like A to the N, B to the N, like those kinds of learning those kinds of rules, right? There's an assumption that that is relevant to language learning, language production, because to be a competent language user requires processing rules of that sort, if I understand correctly. But that's an empirical question, and it's not clear to me that is the case. Similarly, to the point that, well, people's grammaticality judgments can vary. if they're tired, if they're being rushed. But that's true. But actual language use is not reasoned, deliberate, kind of cogitating, right? It's fast, in the moment use. And so if one wants a theory of how linguists go about making these distinctions or distilling these abstract rules, right? That's one thing. And we can ask, are LLMs, can LLMs be good theoretical linguists? But that's separate from the question of, right, are LLMs good models and good theories of language as kind of used and learned by people, right? And a point against the latter is that, well, you know, if they require many orders of magnitude more language input, well, that's a strike against that. But it seems like if they are approximating what actual people are doing, in many cases better than formal theories, then doesn't that in fact make them better models? Maybe poorer models of linguists, but is that the target?
May I respond to that? Or Kyle, do you want to
No,
add to
go ahead.
Oh, okay. So it's not about, nothing here, I think, is about theories of linguists. Linguists are scientists who look at language, but other people can look at language, and linguists can look at other things. Where ultimately looking at human cognition, and I think when we look at human cognition and try to reason about it, we try to come up with the best theory of what we have here. We're not trying to reason about what linguists like or anything like that. It's about what's the best explanation, what's the best theory of who we are, or those parts of who we are that we can start to understand at this point. And I think the A's and the B's and the C's and the D's, maybe that's not about language. And maybe that's one of those things that linguists can look at and are not linguistic in any traditional sense. Maybe, I don't know a priori. It's possible that we use different mechanisms for that, but a theory of who we are should explain how we look at just a handful of those examples and reach systematically those conclusions about it. And also how we can make mistakes about other strings there that we'll correct if we're put in a quiet room or something like that. And I think for that, LLMs are not a good explanation, and other things are. So yeah.
Okay, Kyle, go ahead.
Yeah, I mean, I kind of would just echo, I think, Gary's point that the counting examples feel to me separate in a way that's a little hard to articulate from the linguistic examples. And so these failures, like I said, it's really easy to find all these kinds of failures in reasoning, and I think people like all week have been doing a good job of showing failures in reasoning and failures of common sense and failures of social reasoning and pragmatic. But yeah, it still feels salient to me that it's harder to find examples where it just completely messes up the grammar of a sentence. And it's possible to find those examples like by working really hard at constructing kind of the examples from like the hardest parts of linguistic textbooks. You can find such examples. Yeah.
Okay.
Yeah.
Let me ask you, can you see the open comments in Q&A?
I can, yeah.
I'm going to read the first one, but you eyeball them and see if there's something you give more priority to. Julia asked, there's two comments by Julia. Why do you think tokens aren't as important as we thought? Something close to that was on one of the slides. Sorry if it's not for that.
Yeah, that's a great question. So yeah, tokenization, right, is how models break up text into basic units. And something like GPT uses some variant of a byte pair encoding algorithm, where it's just using frequencies to like get chunks, which ends up being often like chunks at the level of the word, but sometimes morphemes kind of smaller than words or sometimes strange things. Um, I think that kind of tokenization scheme is something that clearly I think almost everyone would agree is not what humans are doing, is breaking things into these discrete and strange chunks such that if something's in all caps, it might be a totally different token than if it's lowercase with no relationship between them. Like it's just clearly not human-like, I think. And yet it turns out not to matter all that much. And if you could tokenize a language model at the level of the character, and the model seems to kind of recover the right representations anyway, you could tokenize in some different and strange way. It might affect model performance a bit, but like you can still get a model that learns interesting language. Um, and so it seems like I don't know, for a while, like tokenization is obviously unhuman-like. There's going to be some big improvement in modeling that comes from figuring out how to make that better and more human-like. And it seems like maybe the lesson that's emerging instead is that these kinds of big networks are robust to different kinds of tokenization, even if they're not optimal in various ways. Um, if we're going to take seriously the idea that this can tell us something about human language, which I think I would, an answer might be, there's kind of an old psycholinguistics debate about what's the basic unit. If you have a word like, friendliness, you could ask, is friendliness when it's processed broken up into friend plus ly plus ness, or is it just memorized and stored as a whole unit? Um, and I think there's kind of an answer suggested by models, which is that maybe kind of all of these things are true at once, right? Like there's some kinds of basic units, but then there's also storage at a slightly higher level and a slightly higher level. And models are kind of integrating over all of those levels. And I think that's reasonably consistent with psycholinguistic evidence in people. And so maybe that's a kind of example of something where I think an insight from thinking about how models are solving some problem could kind of push us in some direction on like an old debate in psycholinguistics.
Okay, Julia has a preemptive follow-up that she wrote before you answered.
Okay.
To counting and patterns, sorry, where am I? Yeah, to counting and patterns, agreeing with Kyle, it seems it's not part of the technological package of language as learned by LLMs, and not part of the minimal viable package of language, which is a new insight to that technology. I wrote a paper on this, said Julia. Okay, that's just an affirmation.
Cool. That would be interesting to see. Yeah.
Okay. By the way, another affirmation you had in another group is, although I don't think this is very useful because it's not Academy Awards or America has talent, whatever, but you were voted for the best paper, and I said, I only added, yes, perhaps, but so far, we're only halfway.
Okay.
Okay. And now, did you see it as you went over the?
Yeah, this Robert Liu question looks interesting. I don't know if Robert.
Say no.
Okay. So,
do you want him up there? I can put him up. Read out.
I can read it also. All right. So about your manipulated input corpus and filtering out a certain class of constructions from the training corpus, do you rely on old school corpus query languages, thus regular expressions, proximity and syntactic tagging? Taggers are not perfect. Is it possible that some positive examples slip through the net and LLMs are smarter than CQL and see them nevertheless? This is a great question. It was the same question a very astute reviewer had for this paper. And it turns out, yes, we were relying on part of speech tagging and regular expressions to remove the AA and N construction. And it turns out that was an imperfect method. And so we ended up having to go back and do a kind of more like basically using a very, very general regular expression that dramatically included like way more false positives, and then go through by hand and pull out the real examples of the A and N. And so yeah, that's a super interesting point, and it definitely gave us in doing that an appreciation for, again, something that's come up a bunch this week, which is data quality issues in training language models are really big because models are so good at picking up on kind of strange and subtle things that are hard to anticipate. Having a really clear idea of what's in the data is important.
Okay, there were others. Did others jump out at you? Otherwise, I'll pick one myself.
Not nothing that jumped out. Yeah, do
Okay,
you want to pick one? I haven't had a chance to read through all of them
I
yet.
don't know who this anonymous attendee is, and I don't know if it's always the same anonymous attendee, but I'll read out his or hers. One of the major, well, you read out.
Okay, yeah, one of the major differences from who we are that keeps getting brought up is the notion that we make binary correctness / grammaticality judgments that are fundamentally different from the likelihood measures underlying LMs. Could the discussion address this? It seems to me that most people make binary judgments when forced to do so. Most of the time in actual performance situations when encountering an ill-formed utterance, people try and make best guess assumptions about what might be intended. LLMs in this way are better fit to human processing than not. Yeah, interesting. So again, this is about how do we make a binary correctness or grammaticality judgment, which is different from the likelihood measure underlying language model. Yeah, I agree. This is, to me, I think this is an interesting open question, even with humans, which is how does whatever knowledge of language people have um, get translated into binary grammaticality judgments or even gradient grammaticality judgments. So this was, I'm always kind of struck by the way that a lot of these debates about language models and debates about methods in language models echo things that were happening in psycholinguistics in the pre-language model era. So I had worked on some papers when I was in grad school in like 2014, 2015 on grammaticality judgments in people and methods for thinking about how to get them. And it's actually getting grammaticality judgments from people can be surprisingly tricky. Also, first, because if you just ask somebody, is this grammatical? They might be bringing like different kinds of social ideas about what grammaticality means into that. They might be overanalyzing it or thinking about the sentence in a way that they wouldn't just naturalistically. Um, if you get binary judgments, that just if you do so right, then there's a forced choice method which is often used where you compare sentence A to sentence B and ask people which is better. Um, this, of course, then you run into this issue of what's the comparison. You can get ratings. The ratings depend on that people will give can depend on what other items are in the list of items that are being included. And so there's a whole bunch of subtle issues there that I don't think are. I think we have a lot of insights about how to do this with people, but it's not perfect or totally solved. And insofar as getting these kind of judgments from models is like a much younger endeavor, I think there's a lot to still think about there.
Okay, Robert Liu wrote back to thank you and to say he wasn't a reviewer.
Okay.
We have a comment from, well, I'll read one from Valérie Payen Jean-Baptiste. We agree that LLM does not represent the human mind, if we can ever say that humans are intelligent. In any case, I had the impression that LLMs were being analyzed too much as objects outside our control, when in fact they're tools in our system of activities. These tools come to us with perceptions, baggage, and values of their designers. The important thing is to know how to train them rigorously to produce and reach our objectives. Thanks for the talk.
Yeah, I think that's kind of an unfortunate result of how things have developed a bit in the field is that like the chat GPT interface is so pervasive as kind of the face of language models that I think it often comes across that these are fundamentally this black box where all you can do with them is like type into your browser and you get like an oracle like answer comes back and that's all we can say about it, which is not the case because you can train your own models. I think that's been even more recent. I think uh, the era where we can train our own language models, which are small enough to train on like an academic cluster, like a relatively small GPU cluster, like the one we have in linguistics at UT, and have them actually, learn enough that you can actually do interesting linguistics with them, as opposed to just having them not have learned anything at all. That's like a relatively recent development in maybe the last 2 years where that's possible. And so I'm optimistic we're going to keep seeing more and more kind of careful linguistic work with language model.
Anna Strasser also has a question. I'm going to comment. I'll read it because I find at this late point, if I give it live, it takes too long. Let them.
Okay.
Great talk. Could you please elaborate a little on what you think meaningful means with respect to your first question? What do you think of the Dennettian difference between competence with comparison of, what did she say? Difference between competence and competence with comprehension versus competence without comprehension? And would you share my provocative statement that humans, linguists excluded, have grammatical competence without comprehension?
Um, so yeah, so the first part, what does it mean to meaningfully learn something about grammar? I think I was just trying to draw a distinction between meaningfully learning something about grammar and kind of being able to do some kinds of grammatical tests and benchmarks just by relying on some cheap bag of tricks, like, knowing that if this word appears in the sentence, it's grammatical, and if this word doesn't, like language models love picking up on tricks like that. If they did that, I think we'd all agree. If they were doing that alone, we'd all agree they hadn't really learned anything about grammar. So meaningful meaning they've learned at least some of the kind of interesting things that we as linguists care about. And my argument was yes, they have. Um, and would I share the provocative statement that humans have grammatical competence without comprehension? I'm not totally sure what it means, but I would agree that humans, right? We know for sure that a 5 or 6 year old child has tons and tons of linguistic competence. Um, but if we ask them, questions about grammaticality or any kind of question about that requires like some knowledge of linguistic theory, right? They wouldn't be able to do it. That doesn't mean that they don't have that knowledge in there. And so I think that is in some ways an interesting analogy to language models.
Okay, terrific. Now we're going to end the session, and it looks like we're switching gears from language to mathematics, but I want to suggest we're not switching gears, and that in fact mathematics and every proposition in every formal proof or verbal version of proof is in fact English, French, German, Latin, Italian. So we're on the same subject, but a special subset of it. Thanks, everybody. Wonderful session, Kyle and Roni.
Thanks. And sorry if I talk too fast, but it's hard to talk to get a sense when you're talking to the black boxes how fast you're going.